Hello, AP Chemistry students. I'm Delaney, and you're up for a treat today because today we will teach you how to do stoichiometry. Stoichiometry is the study of quantitative relationships between reactants and products in a chemical reaction. That definition is all fine and dandy if you're Bill Nye the Science Guy, but for us regular people, stoichiometry is basically converting the measure of one substance to find the measure of another substance. The word stoichiometry comes from the Greek word stoichion, which means measuring elements. You can go from moles to grams, moles to liters, liters to grams, or any other combination you can think of. For those of you who don't know, moles are not the tiny creatures who have funny noses and dig around in the dirt. They are a unit of measure that can be used to find the number of molecules. This number is called Avogadro's number and was named after this guy. We use different numbers to convert from one measurement to another, with moles in the middle. I like to think of stoichiometry as a train station, but you always have to pass through the mole center station. For example, you can go from the mole station to the liter station and back again. The numbers used can be looked at as your fare. You can go from any station as long as you use.
Example 1. How many moles are in 3 grams of carbon dioxide? To solve this problem, first you must look at the periodic table to find the molar masses of carbon and oxygen. The molar mass of carbon is 12.01 and the molar mass of oxygen is 16. Since there are 2 oxygens in carbon dioxide, you must multiply the molar mass of oxygen by 2. Add them together to end up with a final molar mass of 44.01. Then, to convert grams to moles, you must multiply the 3 grams of CO2 by 1 mole of CO2 over 44.01 grams of CO2. With this multiplication, you can cross-cancel, as you may have learned in your 5th grade math class, and end up with 0.0682 moles of CO2. Example number 2. How many grams of H2O are there in the equation CO2 plus 2H yields 2H2O plus C if you have 3 grams of CO2? To do this problem, you must use mole ratio. The mole ratios identify how many moles of product are formed from a certain reactant. Because the coefficient in front of CO2 is 1, and the coefficient in front of H2O is 2, the mole ratio is 1 mole of CO2 for every 2 moles of H2O, or 2 moles of H2O per every 1 mole of CO2, depending on which units you need to cancel. So, for this problem, you would start out just as we did in example 1 by multiplying 3 grams of carbon dioxide by 1 mole of carbon dioxide over 44.01 grams of carbon dioxide. Then multiply that by the molar ratio of 2 over 1, and then multiply that by the grams, or the molar mass, of H2O to get a final mass of 2.457 grams of H2O.
Next, we will be teaching you how to do limiting reagent stoichiometry. A limiting reagent is, in a chemical reaction, the substance which is totally consumed when the chemical reaction is complete. The amount of product formed is limited by this reagent since the reaction cannot proceed further without it. The best way to think of limiting reagent stoichiometry is to think of it in terms of baking. Suppose you want to make cookies. The recipe calls for 1 cup of sugar, 1 cup of flour, and a stick of butter. You have 3 cups of sugar, 2 cups of flour, and 3 sticks of butter. You have enough sugar and butter for 3 batches, but only have enough flour for 2 batches. Because you only have 2 cups of flour, you can only make 2 batches of cookies because obviously you wouldn't bake the cookies with just sugar and butter. In this case, flour would be the limiting reagent because it defines the amount of cookies you can make. The total amount of cookies would be however many you can make with the same amount of flour you have.
Example number 3. Given the equation CO2 plus 2H2 yields 2H2O plus C, if you have 3 grams of CO2 and 3 grams of H2, A, which is the limiting reagent in the formation of H2O, B, how much of the H2O will be produced with the 3 grams of each substance? For A, first you want to set up 2 different equations to convert the grams of each substance to grams of H2O. For this, we would simply do just as we did in the first example, using mole ratios and molar masses. When you solve this, you end up with 2.457 grams of H2O produced from 3 grams of CO2 and 26.76 grams of H2O produced from 3 grams of H2. Because CO2 produces less grams of H2O, it is the limiting reagent because you can only make as much as you can produce with CO2. Which leads us to B, where the answer would be the 2.457 grams of H2O that we found out was produced by our limiting reagent, CO2. Example 4. Given the equation N2 plus 4H2O yields 2NO2 plus 8H2, with 6.25 grams of N2 and H2O, find the A, limiting reagent in forming NO2, B, grams of NO2 produced, and C, excess grams of the reactant that is not the limiting reagent. For A, you would carry out the same process as in example 4A to find the grams of NO2 produced from each reactant. Since N2 produces 20.53 grams of NO2 and H2O produces 7.98 grams of NO2, H2O is your limiting reagent. B is similar to example 3, exercise B. So you would take the amount of grams the limiting reagent produced that you found in the equation previously. So the answer would be 7.98 grams of NO2 that was produced by our limiting reagent H2O. For C, you would subtract the number of grams of NO2 that is produced by N2, which is 20.53, by the amount of grams of NO2 the limiting reagent produces, which is 7.98. Then you get 12.35 grams of NO2 as the difference. Then, since N2 is your excess reactant, you use stoichiometry similar for part A to convert back from grams of NO2 to grams of N2 to find the amount of N2 left over.